In this video, I'm going to go over the mechanism of the acetal formation. There are 7 steps to this mechanism, and we're going to tackle them one at a time. So overall, the acetal formation is a ketone. That's this molecule here, reacting with an alcohol, which is this molecule, in the presence of an acid to give the acetal, which is kind of a diether structure, and water as the byproduct. So the first step in this is the carbonyl reacting with the acid, the H plus in this. So the carbonyl acts as the nucleophile and it attacks the H plus. And what this gives is the protonated carbonyl compound. Like such. So this activates, step 1 is activation of the carbonyl. Okay, so this makes it more prone for nucleophilic attack, and the alcohol can now act as the nucleophile and attack. And what that will give us, again, this is an equilibrium reaction. This is the second step. This is the nucleophilic attack. And what we are going to get is this structure right here with the hydrogen still on it. All right. We eventually need to get to the elimination of water. The alcohol is going to be how the water is created. So this alcohol functionality is going to eliminate. The hydrogen's currently on the ether. So what I have to do is remove it from the ether and transfer it to the OH so I could turn it into water, make it behave as a leaving group. And the way this is going to happen is by a series of proton transfers. So I'm going to take the alcohol, which I have in abundance in this reaction, and that alcohol is going to take that hydrogen off. So it's going to transfer the proton from the ether that I've just created, and it's going to transfer it to the alcohol. So this first step right here is going to give me this. And I'll have the alcohol with the extra hydrogen on it now. All right, so I've taken it off the ether. We're going to call this a proton transfer, or PT for short. All right, so I've transferred the proton away from the ether, and now I'm going to transfer it to the OH. And I'm going to do it just like this. Again, these are all equilibrium reactions. Step 4, again, is another proton transfer. I'll abbreviate it here. And what we get from that is the alcohol with the extra hydrogen on it. It's positively charged at this point. And the ether on this side. Okay, so now this is ready to eliminate water, and let's just do that. So the elimination of water is the next step, step 5. I'll write it under elimination of water. And what we are going to get is an intermediate that has a positive charge, where the water is just broken off. And the ether functionality on there. And I'll draw the water broken away from that molecule with its 2 lone pairs. Okay. This molecule has a resonance structure. I'm going to draw the resonance structure above, where that plus charge is stabilized by the lone pair. Okay. And we'll get something that looks like this, right? And water as the byproduct. If we look at this molecule, right, I have the carbonyl with an alkyl group attached to it that has a positive charge. This is an activated carbonyl just like this structure is all the way over here in step 1, to where I have the carbonyl with a hydrogen on it and it has a plus charge. That made it better for nucleophilic attack. This carbonyl right here is set up for nucleophilic attack as well. I have to put the second group on, right? So what's going to happen is the alcohol is going to attack, and form another ether. Again, I'll show the equilibrium here. This is going to be step 6. And step 6 is going to be, again, a nucleophilic attack. And what we're going to get from that, we're almost at the acetal stage right now. But we have an extra hydrogen on that oxygen. And in order to get to the final product, we're going to have something remove that H plus, and in this case we can use water or we can use another molecule of the alcohol. It really doesn't matter, so let's just use the alcohol, and it's going to take off the hydrogen and give us the acetal. This will be step 7, and again, this is another proton transfer. All right, to summarize what's happened. First step, we activate the carbonyl for nucleophilic addition by attacking the H+. Now that it's activated, the nucleophilic addition can take place. The alcohols are nucleophile. It attacks this activated carbonyl to give this hemiacetal intermediate, or protonated hemiacetal. I have to do a proton transfer to be able to eliminate water from this molecule, so I could add the second ether. Water has to eliminate first, so I use the alcohol to take the proton off. That's the first proton transfer. And the second proton transfer is the alcohol receiving that hydrogen. That's another proton transfer. To get something that looks like this, which is ready to eliminate water from it. Water eliminates from this. That cation is stabilized by the lone pair on the ether. After the water is eliminated, this molecule again is activated for nucleophilic attack. The alcohol again behaves as the nucleophile, does that nucleophilic attack, and gives me this intermediate right here, which is just a proton removal away from becoming the acetal. So again, another proton transfer, and it gives you the acetal.